Okay, so I've got a note here which says one of the big highlights of the day, but there's been so many highlights already. I think I should have perhaps changed that. So what we're having next is a presentation about the 60 gigahertz cnWave technology for smart cities. Not only that, but it comes live from the UK from Anthony Holmes. I think we'll be joining, and here he is on cue. Excellent. Hi, Anthony.
Hello, Brian. Nice to see you.
Now, I'm glad we got you on screen for this bit because I want to see if you blush. I've been told that not only are you the father of Medusa technology, but you bring the magic to the Cambium portfolio. How's that?
Well, thank you. That before, but well, maybe. No, it's an exciting time with the technology that we develop. I always have fun. The team is sort of raring to sort of get on to the next exciting breakthrough, and this is one of those.
Fantastic. Okay, we're dying to hear more. I'm going to leave you to it.
Okay, then. Right, let's go through. So what I'm going to talk about now is enabling smart city. How can we do that? AECOM's technology for security, how can we give them a solution to be able to deploy that around cities? And a city is a very harsh environment to do that. So let's have a look. So, okay, he says. Right, so is this an alternative to fiber or a partner, or a partnership with fiber? Normally the fiber you would trench everywhere. However, we have countries in certain countries that decide not to trench fiber, and they try to string it up as any way possible at all. So, you know, what we want to offer is a new alternative to fiber to work with it, and that is wireless technology. So what is Cambium 60 gig cnWave? We decided to actually release 3 products to cover as much as possible all the different ways you would deploy this initially. So our initial sort of foray into this technology and this frequency has three characters. The V5000 is the distribution node. This is the hub of the technology. It spreads out that 60 gigahertz to not only to client nodes, but also to the user itself with the ports it has. I'll go a little bit more detail into that later. And then we have 2 client nodes. We have a 1 gigabit per second client node, the V1000, and that's 1 gigabit in each direction. So it'll actually do, because it's limited by the Ethernet connection, it's actually will give you around about 1.8 gigabits per second. And then we have a long range, high gain V3000, which in certain countries will give you up to 61 dBm EIRP. In most European countries, that'll be limited to 55 dBm EIRP. We're following the standard here, where we are using Telegraph, and we're going to have a discussion later on with Facebook. Telegraph, we are fully behind and certified and licensed to use that technology. And with that, we are also looking at the AY standard as well and being able to adopt as many of the advantages of that as possible. And then we have the mesh support. So using OpenR techniques, we're able to mesh all these units together to then help with auto expansion, auto healing in your network. The performance of this, that V5000, has 2 sectors inside it, 2 radios independently working, but then bridged together internally. With channel bonding, that device can actually provide up to 15 gigabits per second. We configurations of this are we have point-to-point, point-to-multipoint, and of course the mesh. You can use it in a varying different ways, and we'll talk about those as we go through the presentations throughout the day. And then cnMaestro to manage it. Not only can you manage it with cnMaestro, we also support the Facebook Telegraph network management system, and you can manage this on board as well. So for small networks or point-to-point devices, you can actually just use the device itself. And we've tailored it so what you see in cnMaestro is what you get inside the unit as well. So you can leap from one to the next seamlessly and understand how to manage the units. I mentioned I wanted to talk a little bit more about the V5000. I'm not going to go into all of them in detail, but this particular one we feel is a great way of providing the services you need in a very neat, small package. This unit is capable, as I said, of 15 gigabits per second. It has 2 sectors in there. These sectors can span in total 280 degrees, and so cover an arc of that. Each one of these sectors can support up to 15 other devices off that, and that can be 15 client nodes or up to 2 DNs, distribution nodes, so you can actually spread out that mesh network and link these together. The throughput, as I mentioned, each one of these, you will see each one of these connections is capable from DN to DN or DN to CN, if you use the V3000, is capable of 1.9 gigabits per second in each direction. Antenna. Inside this, the technology that's used is beam steering technology. So as far as installation of this is concerned, you put this up and it can basically scan and find other devices within that, each one of those sectors, 140 plus or minus 140 degrees in total, and plus or minus 20 degrees in elevation. So the way it works is you put this up. It's a centralized management system. So once you've set up your POP, your point of presence, you would then set up a unit, and it will then find the network, any device on the network. It will then have the configuration downloaded to it and then become part of that network. So very simple to install. Alignment of this is trivial. You basically just point roughly in the direction that you want to go, and it will connect. And as I mentioned about the network management in there, our single planar glass, the CN Maestro, enables you to communicate to not only these devices, but all your Cambium network devices on the network. So let's look at some deployments in the city. We have just a basic rooftop to rooftop deployment. You can set up between 2 buildings if you want to interconnect those buildings. Something like the V3000 can work up to 3 kilometers actually in the lowest modulation mode. But if you want high throughput, we actually have a link in trial at the moment at 1.2 kilometers, delivering 3.6 gigabits per second bidirectional TCP throughput. So it's a very powerful device. Then we look at rooftop to rooftop meshing. Each one of these points here is a distribution node, right? And they can link together from rooftop to rooftop, being able to provide a backbone to whatever you want to do within that city center. And what you can do from each of these distribution nodes, as I mentioned, you can drop multiple CNs from these distribution nodes. So these distribution nodes, you can have up to 30 per V5000, 15 on each sector, and you can then basically deliver that interconnectivity to the businesses for fixed wireless access, or you could connect your smart camera on these or other sensor devices, anything that you would need to get information back in a smart city. You can then connect into this mesh. From that as well, you can not only from rooftop to rooftop, but you can also use street furniture on this. So these can be powered from lighting AC using AC-DC converters. But each one of these V5000 is actually capable of powering a .3 AF or AT device off it, and also bridging that information onto this mesh backhaul. So you can have Wi-Fi devices attached to these, sending information back to your central point of presence. Then we look at 5G small cell backhaul. We're also working with customers we've got one customer in Asia where we're actually looking at backhauling 5G. Now, the problem they had is it's easy to put 5G cells in, but how do you connect those back up with a fast, reliable service? When you have cities, as I was saying about the harsh environment, busy roads and streets are actually hard to cross with if you've got fibre in there. So what you can do is you've got these point of presence around your city where you might have fibre links attached to these points of presence. But how do you actually get those to your small cells? One way of doing it is to create a fiber extension using something like the V3000, a point-to-point device, which would actually send a stream up to 7.2 gigabits per second. You can actually send that backhaul stream to a better point of a better position. From that, you can then beam down using a distribution node down to your small cell backhaul, and be able to to your small cells and be able to backhaul those to your point of presence. Likewise, on this, what you can do here is you can turn non-line of sight into line of sight. Basically, by using multiple hops of these devices, you can get your point of presence to your small cell. If you've not got direct line of sight, well, just put in another V5000 and do a multiple hop. Once you're doing that as well, of course, you can also use any relay site to put this client nodes onto it, or to put a Wi-Fi device on there as well. And of course, all this could actually be meshed. So you've got reliability, you've got a self-healing network. So if one of those links up here was to break, the actual it would actually reroute all the traffic through the other direction. So it's constantly monitoring. Each one of these devices knows where alternative routes are to get the data back to that POP. So they're all self-managing themselves. If a link breaks down, they will find a way home to get that data back. So next thing we've got here is we're actually working in, this is in Malaysia. We're actually doing a total respin of a trial network in Malaysia, where we are taking over the network. We're putting in Cambium devices, and we're looking to do this with around about a third of the devices that are currently in there, but still provide the same service. And this is how things have advanced in just a couple of years since the trial was put in place. So we've got a plan here. This plan was actually done in Link Planner. So if you're a Cambium user and you know about Link Planner, people normally plan, we plan about 2 million links a year on Link Planner. And we're able to use Link Planner again to actually look at how to get 60 gigahertz around. So what we've got here is we've got a couple of POPs in the city, and then we link all those together. Again, you can see this 260-degree arc that we're using in each one of these devices to link both CNs and DNs. This is providing a smart city grid for around about 50 to 60 Wi-Fi devices, and that will service around about 30,000 users. We have fixed wireless access on this, where we are delivering data to around about 110 local businesses off this network. And of course, once this is put in place, that can grow, that can expand. You've got this wireless infrastructure in there. To actually drop in another DN is quite, CN is quite trivial, client node. And then, of course, you've got the CCTV backhaul options as well, using something like cnVision in here. We can backhaul cnVision technology through this 60 gigahertz mesh system back to the back into a data center. Just digging in a little bit deeper into this, you can see into the plan. You can see here these black dots are actually the DNs, and the blue dots you see are actually the CNs. So what you can see here is we have DNs all connected to each other, forming this mesh, forming this link back to the POP, turning non-line of sight in a city to line of sight. And from each one of these, we have these CNs, the client nodes, actually delivering the fixed wireless access. So you can imagine we've got data to these businesses. Each one of these DNs has Wi-Fi devices off, giving Wi-Fi services to the people around them. So very quickly you can get into a city and expand out delivering all these services. So with the time I've got, just briefly, just to conclude, basically we are offering fiber-like performances with wireless devices, ease of installation in difficult environments like cities, and giving giving a multi-gigabit wireless fabric. So with that, Brian, I'm going to hand back to you.
Thanks very much, Anthony. We do have one question for you before you go. In unlicensed spectrum, there's a lot of congestion and interference. Can you explain how 50 gigahertz is different from 5?
Okay, so 5 gigahertz, absolutely right. It is, well, both of them are unlicensed. 5 gigahertz, though, has enormous range and capacity capabilities. So, you know, you can basically see a 5 gigahertz signal from 20 kilometers, 40 kilometers away. With 60 gigahertz, we actually are able to utilize some might say, the disadvantages of oxygen absorption and fading to actually to its advantage. So these signals dissipate quite quickly over hundreds of meters. But the other thing as well is we also use technology to help as well. It's not just about oxygen absorption and fade. We actually use things called Bolo codes, and these are codes which we can put in the preamble to so we can actually reduce interference. We can only listen to things that we're interested in, so we can maximize the usage of that data and frequency. We also use TDD. In 802.11ab, it's CMSA. So and that basically means you get collisions. It's a bit like the old .11n devices, until EPMP came along with GPS synchronization and was able to synchronize everything and reduce interference. These 60 gigahertz devices has the same thing. They are all synchronized together. They all transmit at the same time, they all receive at the same time, thus reducing the amount of self-interference as well.
Okay, thank you, Anthony. Thank you very much indeed.